All right, guys, we got a couple tree diagrams to finish off the chapter. I'm on the very, very last page of the packet for chapter 5. And what we've got here is two different examples that I'll show you how to go through tree diagrams again to help us compute probabilities. This one is a Kaiser Family Foundation releasing a study about the influence of media in the lives of young people. And so first of all, we've got a couple different percentages here. 17% of the youth were light media users, 62% moderate media users, 21% heavy media users. And then of those categories, they're broken down even more. So that lends you to believe right away that we're going to be doing a tree diagram. So I'm going to start dividing up my information and organizing using the tree diagram. So just notice that I haven't even read the entire question yet right away, but with all the percentages and then the fact that they're saying of this first category, here's a new percent, it's leading me to think, okay, I'm confused, stop and pause, let's organize the information that we're given. So those are my first three percentages. I have the 17, the 62, and the 21 with their categories. And then I'm going to start reading again here for of the light users responded, 74%, blah, blah, blah. So I'm going to continue my tree diagram now. So here's the finished product of my tree diagram. And so remember that you're also given other information that isn't stated here in the problem. So we do have our first three percentages, light, moderate, and heavy. And when you add those together, they do equal 100% because we don't have an other category for this in terms of media users. But they told us that 74% of the light media users describe their grades as good. That also tells you that 26% would consider their grades not good, which I've labeled my tree as bad. So we're essentially given two different percentages for each one of these categories. So 68 goes with 32, 52 goes with 48. So here's my tree breakdown, and the data is nice and organized. So this question is specifically asking me, according to this study, what percent of young people, so of every single person in this tree, describe their grades as good? And so I'm like, well, you can't unfortunately just look up here and find the people that think that their grades are good and go, oh, 74 plus 68 plus 52. All of those people said their grades were good. Well, that is incorrect math because, first of all, it doesn't add up to 100. It adds up to way more than 100. But you have to look at your tree. These people said they have good grades. These people said they had good grades, and these people said they had good grades, but those percentages are weighted differently according to the category. So remember, there are three different options in order to say that you have good grades. I'm going to write that. We have three options. And I'm going to kind of circle it. These people said they had good grades. These people said they had good grades. And these people said they had good grades. And just remember what we do when we work our way down the tree. You multiply this times this, and you multiply this times this, and you multiply this times this. That's what I'm going to do. And I'm going to come up with those three percentages, and I'm going to add them together. And so here's what my three different options look like. I have the probability that a person said that they were a light user with good grades. And notice I'm using my little and symbol here. I have another option of probability that they are a moderate media user saying that they have good grades. And then the last option was they are a heavy user with good grades. So I'm going to fill in the percentages now. And remember, this and symbol means multiply. So here's my final calculation. I'll zoom in a little bit so you can see, but before I do that, make sure you understand where these numbers are coming from. Probability that the person is a light user is 0.17. Probability they have good grades for that category is 0.74. So that's what I'm doing here. Multiply them together. Same thing for this category, same thing for this category, giving us a grand total of 0.6566. So about 66% of people on this entire tree describe their grade as good. So second question, what percent of youth with good grades are heavy users of media? So this is important because we have a conditional statement here. What percent of youth with good grades, meaning we are only looking at the people that have good grades. We don't care about the people at all that said they have bad grades. So we are looking at the people in this category, and this category. What percent of them are heavy users? And so incorrect math, again, is thinking that, okay, well, let's look at these good grades people, and that corresponds to a category of 0.21. So it doesn't take into account that way. Let's try and remember what the formula is for conditional probability. So here's what the conditional formula looks like and what it tells us. We're asked to find what is the probability that someone is a heavy user of media. This is the question, given the condition here that they have good grades. And so remember the conditional formula, which you should have memorized, means you put an and in between them. So heavy and good, which is something that I calculated earlier. And what I can do here is look at heavy and good, and I would multiply those two numbers together, and that's what would go on top. But remember my divisor, this probability of good, is right here. It's kind of like a division bar. That's how I remember it, that the good goes down here at the bottom. That's actually the question that was asked up here. So this question is actually laid out pretty nicely for us, but what we're given is all of the numbers up here at the top, but what I'm going to show is the heavy and good part, which again is 0.21 times 0.52. That's going to be my numerator. And then the probability of having good grades was this category and this category and this category, which we did up here. So here, you guys, is what all of that looks like. So remember, the probability of being a heavy user and having good grades is 0.21 times 0.52. That's my numerator. And then the probability of having good grades, those were the three options that we laid out up here. So all of this technically gives us this as my denominator. So that's why I wrote from number one. Remember, there are three different options for having good grades. And that gives us a total of 16.63% of youth with good grades are actually heavy users of media. So now let's go into this last example. I actually really like this a lot. This is a very interesting answer once we get the problem all the way finished. But what we've got here is an example on drug testing. And I'm sure this is a very controversial topic for many people, but as you guys know, a lot of employers require drug testing, or at least make you sign a form that say at any time they can drug test you without any warning or blah, blah, blah. And so there's such thing as a false positive and a false negative and whatever. And so sometimes people get screwed when they have to take a drug test. Ask me in class about the drug test that I had to take as a Division I athlete at Butler, because that is an interesting story as well. But what I encourage you to do is pause the video and see if you can draw the tree diagram for all of these percentages here, and see if you can just lay out all the information, and then check your answer with mine. So here's what my tree looks like, and remember, a lot of times when you're given a percent, like 4% of people, prospective employees, use drugs, that means that 96% of people don't use drugs. So you're given kind of two percentages each time. It's kind of tricky to think really hard about like the false positive rate, meaning it tested positive but you don't use drugs. That's this category here of the people that don't use drugs. 5% of them test positive. That's your false positive category. And that means that 95% of them test negative. So good for them. They had an accurate test. Of the people who use drugs, the false negative, meaning they tested negative, but they actually have drugs in their system, so they use drugs. Their test was negative, is 0.1%, and then 0.9% on the other side. If 10% of them test negative, that means that the remaining 90% of them test positive. So kind of a confusing thing to think about in terms of false positives and false negatives, so be careful about that. But what this question is asking us to do is what percent of people who test positive, this is a conditional statement again, actually use illegal drugs. So look at the tree. Where are the people who test positive? We have this category and we have this category. So it's two options, kind of like the example that we just did. So here's what I've written out. I really encourage you to start by using the formula, because this is a given condition. Again, that's our conditional part of the people that test positive, how many of them actually use. So I'm trying to figure out the probability that they use, given, that's where the bar comes in, the fact that they tested positive. So that formula is put an and sign in between them. So use and test positive is going to be this number times this number. And then divided by the given part, this is your divisor. Given that they test positive, we have two different options here. This category tested positive and this category tested positive. Up here in the example that we did earlier, there were three different options there. So I'm going to show the work for the two options that we have for this problem. So where are these numbers coming from? Just remember that the use and test positive is this number times this number. That's my numerator. And then the two different options for testing positive is 0.04 times 0.9 and also plus 0.96 times 0.05, which is right here. So we have two different options here which need to be added together for the divisor. So here's what my final answer is going to look like, you guys. I have 0.4286. I also wrote a little note for you. By the way, when you use drugs but test negative, so a false negative, that's referred to as a type 2 error. You don't need to know that now, but we're for sure going to get into that big time later in the year. And maybe you guys have heard that before, like heard these errors used in other terms, maybe in your AP Psych or something else. When you don't use drugs and you test positive, that's called a false positive, meaning you were innocent but you had a positive test. That's called a type 1 error. So just as an FYI, those are things that I'm trying to like get you aware of because we'll be hitting that big time later in the year. But my final answer here is 0.4286. Let's think about this for a second. That's why I think this question is really interesting. What percent of people who test positive actually use drugs? Almost half. Like, think about that. Less than half of the people who test positive for drugs actually use drugs. Isn't that weird? So of the people who test positive, so take every single person that gets drug tested and has a positive one, how many of them are actually guilty? Less than half. Crazy, right? Anyways, that's all for now. Hopefully that gives you a little bit of an idea on tree diagrams and how they work. My main point of this video is to make sure you start with the formula, because then you won't like forget any of the numbers or forget any of the wings of the tree like we've talked about. Start with the formula, plug in the numbers, come up with your final answer. It's much easier if you can organize the info using a tree diagram. Bring your questions to class. Thanks for watching. See you tomorrow.